earth roads, gravel roads, bituminous pavements, and under rigid pavements we generally consider concrete pavements, either plain concrete or reinforced concrete pavements. If you consider the flexible pavement, normally we differentiate these two types of pavement in terms of their load spreading capability. The materials that we use and the layers that we provide in flexible pavements are in such a way that each one of these layers, normally the upper layer is stiffer compared to the lower layers. So as a result, the load spreading capability gradually goes on decreasing. The load spread has to be done in such a manner that in each layer the stresses that are induced should be less than what can be handled by that particular layer. So ultimately, when you come to the subgrade level, the stresses that are there at the subgrade surface or at any depth in the subgrade have to be reduced to such magnitude that the subgrade can handle. Same is the case for any other layer that you place above the subgrade. The stresses have to be properly distributed. So you have to select proper materials and then adequate thickness of layers above a given layer. But whereas when we consider rigid pavements, most of the load spread is done by the concrete slab. As a result, the foundation has not much of a role really to play in the case of concrete pavements as far as the load spread or load carrying capacity is concerned. The question that should be asked is, should we design pavements? Are there such important structures that require the attention of specialist pavement designers? The problem is that unlike many other structures, pavements do not fail spectacularly. They are not structural failures that cause so much of as a concern, so much of hue and cry. You would not see them failing catastrophically, leading to loss of life within hours, but they fail slowly over some time period. But problem is that bad roads can cause very serious economic loss to the country. They of course cause lots of loss of lives. Okay. But this is what we need to consider very seriously. If you cannot design roads properly, we would be wasting a lot of very important engineering materials and lot of other resources that we have. You may be knowing that most of the roads that we are building for national highways nowadays, they cost almost something like 3 crores to 8 crores per kilometer. There is a great deal of money. Even the Pradhan Mantri Gram Sadak Yojana roads that we are constructing for village roads, very low volume roads, even those roads cost something around 20 lakhs to 30, 40, 50 lakhs depending on the number of cross drainage structures that we have there. That's the kind of money that we are having to spend on roads nowadays. This has to be done judiciously. As I said, anybody can construct roads, but you require great engineering skills so that this money that is spent judiciously. We will also have to appreciate that pavement design is a very challenging task because of the very complex loading conditions that we have. It's not, of course, all other structures are subjected to complex loading, but we consider the loading that is subjected on the pavements to be very complex in terms of the variations in magnitudes, in terms of the variations of types of vehicles that are there, in terms of the frequencies that are different for different types of facilities. More importantly, the materials that we are using for constructing these pavements are very, very complex in nature. We use soils, we use granular materials, we use bituminous materials, we use cement concrete, combination of all these materials in one single pavement. Some of these materials are susceptible to temperature, their behavior is susceptible to temperature, susceptible to load that is applied, various climatic conditions. For most of these materials, behavior is non-linear, and we are having to deal with a combination of all these materials simultaneously, and it is very difficult to obtain proper accurate information about the performance of these individual materials and the performance of the structure which consists of all these materials together. It is very difficult to model them either in the laboratory or on a field scale and then obtain accurate information about their behavior. As a result, it becomes a very challenging task to design payments. What are the main design parameters that we have to select in designing any payment? The first one is, what is the type of payment we are going to adopt in a given situation, whether it is going to be concrete payment, flexible payment, some other unconventional payment, or a combination of these things. Having selected a payment type, what are the number of layers, how many number of layers are going to be provided, what is the material to be used in each layer, what is the thickness of each layer to be provided. If we are talking about concrete payments, what is the joint spacing, what types of joints, whether it is reinforced, unreinforced. Similarly, various other design parameters are to be selected depending on the payment structure that we are referring to. In selecting these design parameters such as thickness, type of payment, number of layers and so on and so forth, we have to basically consider three external parameters. These are parameters that are external to the payment. The first one of these things is the subgrade strength. What is the type of subgrade that we are trying to provide? What is the strength that this subgrade can mobilize, and how we take that subgrade strength into account in designing our payment. The first external parameter that we have to consider is subgrade strength. The next external parameter is obviously the traffic load that is applied, how many numbers, what magnitudes, at what intervals. So this is another external parameter we have to have information about. And third is the climatic condition, in terms of temperature, in terms of rainfall, how it varies over different seasons. All this information is very essential for designing payments properly. If you consider the first external parameter, which is subgrade, the subgrade can be prepared over embankment. Once again, subgrade is nothing but prepared foundation, prepared to proper specifications. The subgrade can be over an embankment, or it can be in cutting also. We are concerned about what is the type of soil that we are using and what is the strength that can be mobilized for this particular type of soil if it is properly compacted and properly prepared. And at times we are also interested in what are the drainage characteristics of the subgrade material. So we take into account all these parameters when we specify what is the type of subgrade that we are providing. Similarly, in terms of vehicular loading, we are interested in numbers or volumes, how many vehicles per hour, how many vehicles per day, or how many vehicles that the payment has to carry over its life period, 10 years, 12 years, 20 years. What type of vehicles are going to be using this payment? Heavy vehicles, small vehicles, mostly empty vehicles. What are the loads that they carry? Are they very heavy? Are they following legal limits? Is there overloading? What is the speed at which these vehicles are following? Because depending on the speed, the characterization of the materials is going to be different. The response of the payment is going to be different depending on the speed of the loads or speed of the vehicles. So are these vehicles stationary? Are we constructing payments to carry stationary vehicles, or are we going to have only slow moving vehicles at a given stretch of a road or given stretch of a facility, or do we expect over a given stretch we are going to have only fast moving vehicles traveling at 60 kilometers, 100 kilometers or even more? So the designs are going to be different for each one of these situations. Coming to climatic parameters, we have to consider about rainfall. What is the total rainfall that would be there in a year, how it is going to be distributed seasonally, and we would also see how this rainfall is going to affect the performance of the payment and affect the strength of different layers such as subgrade, granular materials, how much of water is going to be going to the payment, how it is going to damage the bituminous layer and other types of payments. We also need to be collecting information about what are the maximum temperatures the pavement is going to subjected, because materials like bituminous mixes are highly susceptible to temperature variations. They become very soft subjected to very high temperatures. They can become very hard, very stiff subjected to very low temperatures. So we need to understand the maximum temperatures and minimum temperatures the pavements are going to be subjected to, and also the duration during which the maximum temperatures are going to be there, and duration during which the lowest temperatures are going to be there, how the temperature